Hello and welcome to The Explainer. Today, we're diving into AI agents. Now, you might not even know the term, but I guarantee you're already using them, probably dozens of times a day. So what exactly are they, and how do they work? All right, let's break it all down. So let's start with the really big question. What if your software could do more than just follow a strict set of commands? What if it could actually observe the world, think for itself, and then act on its own? Well, that right there, that's the fundamental idea behind an AI agent. And this is really the key difference. A traditional program, like the calculator on your phone, is amazing at what it does, but it's completely rigid. It just follows fixed instructions. You put in 2 plus 2, it's going to give you 4, every single time. But an AI agent, like a self-driving car, is way more dynamic. It's constantly sensing the world around it and making decisions in real time. It isn't just following orders, it's actively trying to achieve a goal.
To really get our heads around this, I think the best way is to imagine we're climbing a ladder. We're going to start with the simplest kinds of agents at the bottom and work our way up to the really smart ones.
So at the very bottom of the ladder, the first rung, we have what are called simple reflex agents. And you can just think of these as pure if this, then that machines. They only react to what's happening right this second, with absolutely no memory of what came before.
A perfect example is probably sitting on a wall in your house right now, a thermostat. It doesn't remember that it was cold 5 minutes ago. It has no memory at all. It just knows one simple thing. Hey, the room is now below 20 degrees, so its one and only action is to turn on the heat. Simple, direct, and totally reactive.
Okay, let's take a step up the ladder. The next rung adds a really crucial ingredient, memory. These are called model-based agents. They actually keep an internal model of how the world works, and they use information from the past to make much better decisions in the present.
And having a memory is an absolute game changer. Think about it. A self-driving car that saw a cyclist a few seconds ago can remember that person is still nearby, even if they've slipped into a blind spot. That internal model lets it make way safer, way smarter decisions than an agent that can only react to what's directly in front of it.
All right, now things start getting really interesting. We're moving from just reacting to being proactive. Goal-based agents don't just consider the past and present. They actually look ahead to the future. You give them a specific goal, and their entire job is to figure out the best sequence of actions to get there.
And you use these all the time without even thinking about it. Every time you punch an address into a GPS, it's not just reacting to where you are. It's looking ahead, considering thousands of possible routes and turns, all to achieve one single goal, calculating the absolute best path to get you where you want to go.
But what happens when there's more than one way to reach a goal? Which one do you pick? Well, that's where utility-based agents come in. They add this extra layer of preference. So instead of just finding a path, they find the best path based on some kind of utility, like what's the cheapest, or the fastest, or maybe even the most scenic.
And that right there is the key. It's not just about getting the job done. It's about getting it done well. A flight booking agent doesn't just find you any flight. It weighs the options to find the one that's, say, cheaper and has a shorter layover, maximizing its usefulness or utility to you.
And here we are. We've made it to the very top of our ladder with learning agents. And honestly, this is where things get incredibly powerful. These agents don't just operate with a fixed set of rules. They actually get smarter and smarter over time by learning from experience.
You see this in action literally every single day. Your Netflix or Spotify recommendations, they aren't static, right? Every time you watch a movie or like a song, the agent learns a little bit more about what you like. It's constantly adapting itself to give you better and better suggestions. It is learning in real time.
So, we've climbed this whole ladder from the simplest reflex agents all the way up to these super smart learning agents. But what's the one thing they all have in common? Well, if you look under the hood, every single one of them, from the dumbest to the smartest, runs on the same simple continuous loop.
It's this powerful 4-step cycle that just runs over and over. First, the agent perceives the world. Think of a chatbot reading the message you just typed. Then, it reasons, running through its logic to decide on the best possible response. Next, it acts by actually typing out and sending that reply. And for those top-of-the-ladder agents, there's that final crucial step. They learn. They look at the outcome. Maybe you gave the conversation a thumbs up, so they can do an even better job next time. Perceive, reason, act, and learn. That's the loop.
Okay, so we've covered the what and the how. But that brings us to the most important question of all. So what? Why does any of this matter to you? The simple answer is, because they are already everywhere, and they're making critical decisions in huge industries. In finance, you've got agents executing stock trades in fractions of a second. In healthcare, they're helping doctors analyze X-rays to spot diseases earlier. I mean, even in our own homes, they're vacuuming our floors. This isn't some far-off science fiction. This is our world, right now.
At the end of the day, it's important to see that AI agents aren't just a clever feature. They are a true foundational technology. They're the engine that drives that deep personalization you now expect from services like Spotify. They're the automation that saves companies billions of dollars. And they are, without a doubt, the building blocks for our future. Everything from truly smart homes to fully autonomous transportation.
And all of this leaves us with one final and really important question to think about. We've watched these agents evolve from a simple thermostat to these incredibly complex systems that can actually learn and adapt on their own. As they get even more capable, we have to ask ourselves, where do we draw the line? What decisions are we truly comfortable letting them make for us? That's the conversation we're all going to need to have. Thanks for watching.